Hello everyone, welcome back to my channel. I am Abhishek Paudil. I am a tutor of fluid mechanics and hydraulics subject in civil engineering. Today I have got a problem from hydrokinematics, which is chapter number 4 of fluid mechanics. Okay, hydrokinematics means the study of the motion of the fluid particle without considering the cause of motion. You already know about it. Now I have taken a question which is a three-dimensional velocity field. You can see here velocity of flow field is given as v vector, that is minus x I vector plus 2 ij vector plus 5 minus j z k vector. Okay, and this question aims you to determine the equation of streamline that passing through the point 2, 2, 1. Okay, here this might be very useful to you for final examination. So please watch it meticulously. Now I am going to write like a three-dimensional system, that is x, y and z axis. Okay, x, y and z axis. In x axis you call it u, velocity component in x direction u, in y axis this is v, and in z axis this is w. You have given a velocity field here, so you easily get the value of velocity component, that is u is equal to minus x and v is equal to 2y and w is equal to 5 minus z. Okay, I have extracted this velocity component from a velocity field, and now these are the component of velocity in three-dimensional system. Okay, now let's go to find out the streamline for these three-dimensional system. For the calculation of streamline, you have a three-dimensional equation. Okay, that is for two-dimensional system you have written you have been writing like this. Okay, dy by dx is equal to v by u. This is the equation to determine the equation of streamline. Okay, for two-dimensional system. But for a three-dimensional system you have to rearrange like this. Okay, you are not going to solve by using this equation, but you have to do like dx, dy and dz. First write dx, dy, dz. Okay, first write dx, dy, dz, and then is equal to divided by u and divided by v and divided by w. Okay, this is written like this for three-dimensional system. For 3D streamline calculation, if you are supposed to find out the three-dimensional streamline, then you are supposed to use this equation. Okay, not this one. This is for two-dimensional system, you have been doing this, but in three-dimensional system you have to do like dx by u, dy by v, dz by w. Just like this, if you erase this, then this is going to be dy divided by dx is equal to v by u. It's the same as this one. Okay, I have rearranged this in order to find out the streamline in three-dimensional system. Okay, I hope you understood. Let's go to use this equation. Okay, let's go to use this equation in order to determine the streamline in three-dimensional system. I have extracted u, v, w. Now I'm not going to use this, I'm going to use this first equation. Okay, let's use the first equation. Now I have got u is equal to minus x, v is equal to 2y. Okay, I have got u is equal to minus x and v is equal to 2y, and w is equal to 5 minus z. Okay, and w is equal to 5 minus z. And now I am going to use the first set equation. Okay, using first set, that is dx divided by v, u is equal to dy divided by v. Okay, let's use this equation in order to determine the equation of streamline. Okay, and later on we use this equation. Okay, later on we use this equation. First we are going to use this equation, and second we are going to use this equation, that is dy by v is equal to dz by w, in order to determine the streamline in three-dimensional streamline equations. Okay, let's use the first equation using first set, that is I. using first set, that is I. Okay, let's substitute u and v here. Okay, let's substitute u and v here to get the equation. Okay, let's proceed. Dx divided by u is how much? U is minus x, and dy divided by b how much? B is 2y. Okay, let's arrange the family. Okay, arranging the family here. Family is already arranged here. Dx divided by x divided by 2. Okay, let's integrate. On integrating, we are going to get how much? Integrating. Okay, let's do a definite integral here. The point is given, that is 2 to 1. We are supposed to find the equation of streamline which passes through the point 2 to 1. When the question gives you the point, then the point is initial point. You have to write like x naught, y naught, z naught. Okay, these values given are x naught, y naught, z naught, and now you are going to use the x naught is equal to 2, y naught is equal to 2, and z naught is equal to 1. Okay, in every questions it is not mentioned, it does not mention the initial point, but you have to put the given point like this, x naught, y naught, z naught. Okay, in every problem. Okay, this is not given like starting point, initial point, so that's why you have to take this 2 to 1 as a x naught, y naught, z naught. Okay, and now let's do the definite integral. Let's use the concept of definite integral. Definite integral, that means definite integral means we are not going to write c here. You can also do by putting c, which is called indefinite integral, but I am going to do this by putting the definite integral. This is very useful in the case of determining the streamline equations, so that's why I recommend you to use this definite integral concept in every numerical. Okay, you can also go from indefinite integral, that's okay. Okay, now let's put the definite integral here, x naught to x, that is dx divided by x, which is minus is here, and 1 by 2 is here, integration y naught to y and dy by y. Okay, this is the integral, definite integral. You have to put the limit in both sides. This is called definite integral. Okay, okay, now let's do the integration. Integration of dx divided by x, that is ln x. Okay, ln x, dx divided by x, that is ln x. I am proceeding here, ln x minus ln x. Okay, minus ln x, that is x naught to x, is equal to, and this is 1 divided by 2 ln y. Okay, ln y, which is y naught to y. Okay, y naught to y. Now let's put here ln x minus ln x naught is what? Ln x divided by x naught. Okay, I have directly written here ln x divided by x naught after putting the limit here, and 1 by 2, which is ln y minus ln y naught, how much? Ln y divided by y naught. Ln y divided by y naught. Ln y divided by y naught. So I can also write the like this, ln x divided by x naught whole power minus 1. Mathematically I can write like this, y divided by y naught, whole power how much? Whole power 1 divided by 2. Okay, I can write like this, and I can eliminate this ln sign. Okay, I can easily find out the equation x divided by x naught whole power minus 1 is equal to y divided by y naught whole power 1 divided by 2. Okay, you can write like this, and now it is inverted minus 1, so that's why x naught divided by x is equal to y divided by y naught whole power how much? 1 divided by 2. Okay, let's put the value of x naught and y naught here. Let's put the value of x naught and y naught. X naught is equal to 2, y naught is equal to 2. Let's put here. Okay, let's proceed from here. Okay, x naught is how much? 2 divided by x is equal to y divided by y naught is how much? Y naught is also 2, which is equal to how much? 1 divided by 2. Let's squaring both side. Squaring both side. 4 divided by x square is equal to y divided by 2. And finally I have got x square y is equal to 8. This is our required equation of streamline. Equation of streamline. Streamline, okay? Streamline. This is a required equation of streamline. You can find out the equation of streamline like this. Okay? This is in terms of x and y. You can also plot this in graph. You can also plot this in graph like this. This is x, this is y. You can plot it to get the required streamline. Okay? Okay, now I have completed this using the first set. Now let's go get into the second set. Okay? Second set, that is using second set. Second set. Let's use the second set. Second set in order to determine the equation. Okay? Okay, using second set here, let's use the second set, that is dy by v is equal to dz by w. Okay, this is the second set in order to find out the equation of streamline. Okay, let's substitute the value of v and w. Let's substitute the value of v and w. V is how much? Ty divided by v is 2y, and dz divided by w is how much? W is 5 minus z. Okay. This is the integration is done like this. Now let's apply the definite integral in this case. Okay, you can also use indefinite integral in order to find out the equation, the final expression. But I am going to use the definite integral, which is very easier and which is indispensable to find out the streamline equation. So that's why I recommend you to do the definite integral. Okay, so it is written like this: y naught to y and z naught to z. Okay, it is written like this. Now integration of dy by y, how much? 1 divided by 2 ln y, okay, ln y, which is equal to y naught to y. And now integration of 1 divided by 5 minus z, how much? ln 5 minus z, but you have to take care about this negative sign, this minus 1 here, so which is going to make this minus. Okay. Okay, this is z naught to z. Okay, this is a limit which is called definite integral, and you can put the value of y naught and z naught from here. Y naught is 2 and z naught is 1. So to get the equation of streamline. Okay, let's simplify this. Let's simplify this. Ln y minus ln y naught, how much mathematically? Ln y minus ln y naught is ln y by y naught. Okay, so 1 divided by 2 ln y divided by y naught, and is equal to, this is ln 5 minus z minus ln 5 minus z naught. Okay, okay, I am written like this: ln 5 minus z, which is equal to minus sign is here, minus ln 5 minus z naught. Okay, this is written like this, and you can mathematically write this like ln y divided by y naught whole power 1 by 2, 1 by 2. Ln y divided by y naught whole power 1 by 2, you can write like this. In order to eliminate this ln, you must get the equation in terms of x, y, z to plot the equation of streamline. Okay, and ln a minus ln b, how much? Ln a minus ln b, ln a by b, 5 minus z divided by 5 minus z naught. Okay, it is written like this, and you can also put this minus over here in order to eliminate the natural log sign. Ln y divided by y naught whole power 1 by 2 is equal to ln 5 minus z divided by 5 minus z naught whole power minus 1. Okay, minus 1. Let's eliminate the natural log sign to get the equation in terms of y and z, and let's substitute the value of y naught and z naught here. Okay, okay, I am going to erase this. Now let's substitute y naught and z naught. How much is y naught? Y naught is 2 and z naught is how much? 1. Okay, let's substitute this. Let's eliminate the natural log sign. That is y divided by y naught is how much? Y naught is 2 whole power 1 by 2. 1 by 2 is equal to 5 minus z. 5 minus z divided by 5 minus z naught. Z naught is how much? 1. 5 minus 1 whole power minus 1. Okay, minus 1. And you can proceed here. y divided by 2 whole power 1 by 2 is equal to 5 minus z divided by how much? 4 whole power minus 1. 5 minus z divided by 4 whole power minus 1. Let's reverse this. Y divided by 2 whole power 1 by 2, it can be written as 4 divided by 5 minus z. Okay, you can write like this, 4 divided by 5 minus z. And now let's square this. Squaring, that is y divided by 2 is equal to 16 divided by 5 minus z whole square. Okay, it is written like this. And now the equation, last equation in terms of y and z, that is equation of streamline. That is 5 minus z whole square y, 5 minus z whole square y is equal to 32. This is the final, this is the equation of streamline which passes through the point which passes through point 2, 2, 1. This is the equation of streamline. We have got two equations of streamline in case of three-dimensional velocity field. We have already done the two-dimensional velocity field of unsteady as well as steady. I recommend you to practice this question in terms of unsteady flow, because this is the steady flow I have done here, the steady flow, because time dependency, there is no time dependency. So I'll give you one question, I'll in the comment box, description box, and please do that question. Okay, this is the homework for you. This is the steady flow, and I will give you the unsteady flow, okay, of three-dimensional flow system. So you are supposed to follow the same procedure like this and to solve the problem of unsteady flow. Okay, thank you so much. See you in the next video. Okay.